Good afternoon, and welcome to the third Climate Action Symposium. I'm Paul Joskow from the Department of Economics, and Jessica Transick, who's right here, please stand up, is from IDSS, the Institute for Data Systems and Society. We organized and moderated this symposium. I'm going to make a few opening remarks and overview of what we'll be covering here today, and then I'll turn it over to Jessica to moderate the first two panels. This symposium focuses on progress in research and development and potential deployment of selected technologies that can significantly reduce or eliminate carbon emissions created by the combustion of fossil fuels to generate electricity. The symposium will also look at the use of clean electricity to decarbonize other sectors of the economy, here today focusing on the transportation sector. The next symposium in February, on February 24th, will focus on decarbonizing other sectors of the economy. Finally, we'll also discuss today the challenges and opportunities faced by developing countries as they seek to increase access to electricity and to respond to growing demand for electricity as higher incomes lead to more appliances, equipment, and electricity utilization, but within the context of a carbon-constrained world. Why electricity? Well, the first reason for looking at the electricity sector is because the electricity sector accounts for a significant fraction of greenhouse gas emissions. In the US, it's about 30%. It used to be higher. It's roughly tied with the transportation sector. On a global basis, it accounts for about a quarter of greenhouse gas emissions and is the largest individual sector. If we focus only on CO2 emissions, electricity generation accounts for about 40% of global CO2 emissions, according to the most recent International Energy Agency report. But the magnitude of the emissions from the electricity sector is only one of the reasons for the great interest in decarbonizing the electricity sector. Electricity is at the heart of a global economy-wide decarbonization strategy with three major components. The first component of this strategy is indeed to decarbonize the electricity sector by dramatically expanding zero-carbon electricity generation to create what I call clean electricity. CO2 emissions from the electricity sector are created by the combustion of fossil fuels, which account now for about 2/3 of global electricity generation. Accordingly, decarbonization of the electricity sector requires replacing fossil fuel generation with very low or no carbon generating technologies and the associated support technologies, in particular storage, if we rely heavily on wind and solar. The second component of this strategy is to expand the use of clean electricity to replace oil in large portions of the transportation sector. And finally, the third component of this strategy is to use clean electricity to replace oil and gas in buildings, heating, ventilating, air conditioning, water heating, electric motors, and other applications, as well as in other end-use sectors. Turning first to decarbonizing the electricity sector. There are many technologies that can potentially play a role in decarbonizing the electricity sector. Wind and solar, along with storage to deal with intermittency, nuclear fission, hydroelectric generation, fusion, fossil fuels with carbon capture and sequestration, green hydrogen, and others. And as we'll learn today, there's no single technology that's going to decarbonize this sector. It's going to be a combination of technologies and a portfolio of technologies that fit into an electric power system. Today, we're going to focus on solar, on storage, on nuclear fission, on fusion, on the greenhouse gas mitigation front, reflecting some of the research going on at MIT. Now, we've made some progress, at least in the US, on decarbonizing the electricity sector. Just to give you a sense from this chart comparing 2007 with 2017. A significant amount of coal has been displaced primarily by natural gas. Wind and solar have increased significantly. I note that nuclear generation has been steady and contributes to 20% of US electricity production. So we've made progress, but there's still a lot more to be made to meet the goals of moving this sector towards a very low level of carbon emissions. On the demand side, or the electricity utilization side, there are also many opportunities to expand clean electricity use to replace fossil fuels in other sectors of the economy. Here's just a forecast of the growth of electric vehicles in different countries. I'm not putting it up here because I necessarily believe in that forecast, but it shows that part of the strategy is to migrate that sector from gasoline and diesel fuel to electricity. And we'll focus on transportation here today and leave other sectors to the next symposium. And finally, we must recognize differences between developed and developing countries. We tend to look at this, many tend to look at this from the perspective of the US and Europe and Japan, but things may look very different from the perspective, especially of sub-Saharan Africa. For developing countries, increasing access to electricity, and importantly, supporting increased utilization of electricity as incomes rise are very important. How are these development goals affected by carbon constraints? And that's something we need to be very much aware of because developing countries will be growing both economically and potentially in terms of their electricity utilization and carbon emissions much more quickly than developed countries in the decades to come. Now, how are we going to work today? You'll note that we have a large number of panelists, many of them from MIT, connected with MIT. We wanted to give you all a taste for research going on in this area at MIT. So bear with us as we try to manage a large number of panelists who will be speaking with us today. Following a discussion among the panelists, there'll be time for audience questions. If you have a question related to the topic of a particular panel and you'd like the panelists to address your question, please text MIT Climate, one word, capital letters, 37607. So text MIT Climate to 37607, and we have a little machine up here that forwards the questions to the moderator. We'll take as many questions as we can, although time may be limited for some of the panels. Let me now turn the symposium over to Jessica Transick, who'll lead our first two panels. Thank you.